afternoon, everyone. On behalf of the Department of Commerce, Economics, BBA of Cooch College, I welcome all the respected dignitaries, teachers, scholars, students, and all the other listeners present over here on the second and final day of the 2-day special lecture session. It is a proud privilege and matter of extreme pleasure that today we have Professor Dr. Subhasish Bhattachariya, the Honorable Professor of Economics in Sidhu Kanu University, amongst us. He will be delivering lecture entitled Fundamentals of Time Series Data Analysis and its Application to Commerce, Economics and Management. He is our ex-colleague and is having a huge extent of teaching and research experience in the field of economics. He has successfully conducted many minor and major research projects and delivered lectures as resource person in many national as well as international conferences. He has many minor and major research projects, and he has many national as well as international publications too in research journals. We wished a warm welcome, sir. At the onset, I would like to request our head of the department, Professor Abhijit Roy, HOD Commerce, to say something to introduce Professor Bhattacharya. Sir.
Good afternoon, everyone. At first, I welcome Professor Dr. Subhasish Bhattacharya, Professor in Economics, Department of Economics, Sidhu Kanu University. Just now, our principal sir has joined with us. It is our privilege that Dr. Pankaj Kumar Devnath, Principal Cooch College, has joined with us. So immediately after introduction, I shall request Dr. Pankaj Kumar Devnath, Principal Sir, to say something about this program. Good afternoon, all the students who have joined. I think this special lecture series has been arranged for the benefit of yours, and I surely hope that this lecture will enrich. Along with you, all of us will be enriched with the lecture that will be given by Dr. Subhasish Bhattacharya. He was our ex-colleague. So, on behalf of whole Cooch College family, I welcome Dr. Subhasish Bhattacharya. Now, I shall request Dr. Pankaj Kumar Devnath, Principal Cooch College, to say something about the program. Dr. Pankaj Kumar Devnath.
So, very good afternoon to all of you. So, this is really again an opportunity for all of us that the Department of Commerce, BBA, and Economics jointly have taken special initiative to organize today's very important lecture, which will be delivered by Professor Subhasish Bhattacharya, who is presently working as the professor at the Department of Economics of Sidhu Kanu University, Purulia. And as you have come to know from the speech of Professor Abhijit Roy, HOD Department of Commerce, that Professor Bhattacharya, though new to you, all of you the students, you do not know him, but he worked in our college as the teacher in the Department of Economics for a long time. So just before some years ago, he get the opportunity to join in first in Malda College, Malda Gorbanga University, and then he immediately joined as associate professor in the Department of Economics of Sidhu Kanu University. Now we are very happy that he has become professor of that university. So we are also really very lucky that a teacher from our college has achieved this type of success. So for me and for I think for all the teachers of Department of Commerce, the senior teachers and also senior teachers of BBA, we are again just with our very close friend, Professor Bhattacharya. Though it is a virtual platform, still we are feeling happy. So from the chair of the principal and from all the members of our Cooch Behar College, I do welcome to this platform Professor Subhasish Bhattacharya who will deliver this special lecture and giving his concept for the same. I think the students of all the departments will definitely be benefited by his lecture, and he will deliver on a very important topic of the statistics, that is the time series, and how it can be applied in different practical fields. I think this is the topic of Professor Bhattacharya, so it will be very helpful for the students, definitely. The teachers will also be benefited from his lectures, and this is a part of our initiatives that has been taken by all the departments of our college to organize some special lectures, particularly for the Department of Students, and also to organize some webinars. So though we are not getting opportunity to meet you in offline classes, still we are trying our best to reach you through these different online methods so that your teaching and learning will not be hampered and it will be going on. I think you take part in the deliberation and you will definitely will not be marked. You please ask your questions, any doubt if there, definitely you please ask to Professor Bhattacharya. I think he will clear all your doubts. And I wish a very successful special lecture of this day today. So thank you again, all of you present here. Over to Professor Roy.
Thank you. Thank you very much, sir, for your introductory lecture. As you said, that the students will be immensely benefited by this special lecture on time series analysis. So this is our endeavor to enlighten you in this time of pandemic situation with the light of knowledge. So no more introduction, and with this I welcome Subhasish Bhattacharya, and before his lecture I want to request everyone that please keep yourself muted, and if you have any queries, if you have any question, and if you have any doubt, please write in the chat box. After this lecture, he will discuss your questions after his lecture. Okay, please write in your chat box, and during his lecture, we will keep ourselves muted. So no more today, and the stage is over. Is yours, Subhasish. I welcome you.
Thank you, Tamojit. Honorable Principal Sir Pankaj da, and my past all colleagues from Commerce Department, especially Ravi, my friend also, and Tamojit is also like my brother, and the persons Shankar, Shubhendu are there, and Economics Department, the the name I just cannot remember it. Sushomon, right. Sushomon is also a very nice guy. And Shumon is the new. When I go to in future, when I go to Bhuj, surely I will meet all of you. And I just fortunate to get such an opportunity, which my old college always remember me during such an occasion. And if I do some benefit, I think I will be obliged for this. So so today already 19 minutes actually it is gone. So today I am directly going to my part, that is it is purely for the students of UG level. And time series, I will try my best to do the thing without interacting any mathematical tricky things like this. But time series it is actually related with mathematics to some respect. So sometimes it will come automatically, but those who are not quite but it becomes easy in mathematics, it is not a problem. You just I will try my level best to understand you, that to give you the understanding like this, that is what is time series. And basically I'm just so any question is there, you can ask after the session. And so I think I will go to that's the presentation. Okay, I'm audible now perfectly.
Yes, you are audible, but your screen is small, I think.
Small. Actually, it is a PDF. Okay, this will be not so much things. So much things are not in the screen. Just some understanding, because I have to share this screen simultaneously with R.
It is visible. It is clearly visible now.
Okay. So we are starting with we are starting with, suppose, a relationship. There are so much kinds of relationships: relationship between man, and relationship between man and woman, and relationship like this. So I consider a relationship. You are familiar with that in mathematics it is called functional relationship. That means which is functioning, a relationship between two frames, it is functioning. So I am considering a relationship like this, that is like today we are in West Bengal, and there are so much scholarships are there. So one such scholarship is mainly for the female students, that is the Karnash. So I take an example from that is suppose under such pandemic situations, students get the scholarship and they will recharge their mobile from that scholarship to avail the online facilities which is provided by the institutions like colleges, was. And that relationship is suppose it's a linear relationship like this. That is, if such a relationship, that is Y is denote the data recharge and X denotes the scholarship. And now suppose I found a relationship like this, that what is the data recharge is equal to ₹50 plus 1/4 of Konasi scholarship what the students get. That 1/4 is represented by 0.25. So this is the relationship between our students who receive the Konasi scholarship. Then who don't receive any Konasi scholarship, that means for his that X is equals to 0, and he clearly found that in the place that what amount data and recharge, that is 50 only. Now the students who get 800 scholarship, so you put 800 there and you find out the value is 250. And if it is 1000 there, then you find out the value is 300. That means these are the data recharge behavior, suppose, of 3 students. That is whose scholarship levels are 0. There is no scholarship that female students are not receiving, and the other two are receiving 800 and thousands. So they are doing the data recharge by that way. So such relationship is called a deterministic type relationship. That means, you know, if you get the Konasi, then you make some influences over the data recharge, because you can recharge your mobiles to avail the online class more frequently or to do something other else. Now, under such situation, suppose, and you are very much today familiar with that kind of platform like Netflix and Amazon, and it is found that the family season 2 is open releases. It is already released. Now family season 2 is released. So what will happen? Surely some students are interested to see the movie, that episodes is what they are called. That is episode based movie, like family season. So they will recharge their data. So, but I assume earlier that data recharge is from only for the Kannas, and Kannas amount will be scholarship amount will determine what amount of data recharge I will do. That actually becomes like this. That actually becomes depending on the situations like that is family season 2 releasing. So deterministic relationship, which was determined by Bernasi, what amount of data I will recharge, and that is influenced by the family season 2, and data recharge behavior of mine is changed. So such deterministic relationship is fake to explain what will happen if such outside factors are there. That means like releasing of family season 2 or family man 2, these kinds of things. So these are called in statistics. These are called that is something unobservable things are also influencing our life. That is data recharge is not only influenced by the scholarship. It is influenced by something unobservable facts like family season, like to make some other online classes or other online things which you are doing. Such relationship is captured by the statistics, and such relationship, when we consider the several other variables, these are called stochastic relationship. These are called statistical relationship or stochastic relationship. That means earlier what I'm considered that this data recharge is only depends on scholarship. It is now changed. It is now changed to what? It is now changed to, that is, data recharge is depends on scholarship as well as something unobservable facts. That is the thing of stochastic, and it is more valid, it is more scientific to consider by such. I think up to this it is okay. So how mathematically or how we can calculate this? So this relationship, what we assumed earlier, that x is equal to 50 plus 0.25 into x gunya, that means the scholarship amount, and plus some unobservable facts, which is known as Q. That is, we do not know which things are there. So suppose in case of like this, that is family man 2 releases, one student's behavior or the 3 students' behavior like this. If there is events like family man 2, they will recharge more 100 rupees. And if it is there is events like family man 2, they will recharge nothing. So look, there are 3 students we already identified whose scholarships are 0, 800 and thousands. And what is their earlier data recharge behavior, that is 50, 250 and 300, which I already told you in the earlier things. Now, if it is 100, if there is family man, then it becomes 150, 350 and 400. So things are changing. That means such unobservable facts influences our life, influences our behavior. So when we read any kind of data, specifically in time series, we have to be careful about such unobservable facts. We must be careful about such unobservable. So this is my purpose. That is why I am considering such an example. So how such things how such unobservable things can be captured? That can be an important part. And suppose we take an example that some specialized thermometers are used by Indian Meteorological Department to collect the day temperature data. Suppose this is an example. So what is the thing? IMD collects the day temperature on the basis of what they found in the normal sometimes of the day, and they collect it and note down it and produced for us. That is, these are the day temperature. These are some. They are mentioning in their results. So this is an event. Suppose this is an event, because we are starting with some data. So here in economics, especially we are very much interested to explain anything in terms of input-output relationship. That means what I get and what I produce. How changes are there? What type of changes are there? So in this data collection behavior, if I put this data collection behavior into input-output frame, then what is my input? The input is air temperature, and that is collected by the IMD, and this inputs are what? Air temperature, which is varies as per location. For example, in Kolkata, it is a low altitude, highly urbanized, PM particles are more in the air, and automatically temperature will be high. But in compare this in terms of Cooch Behar, that is no such huge population density, and or except only the district town, no such huge population density. Altitude is something different. Not so much cars are there, automobiles are there. So there is different levels of temperature. So such a suppose in case of considering the case of Kolkata, such a rise in PM particles mainly due to automobiles and air conditioning research. That is, AC machines are there controlling our life. So the collection of day temperature is varies as per season, or suppose in holidays temperature level varies. So these are the unobservable facts which is within our input level. So not only the unobservable facts are in the outcome in one side, it is in both sides. That means when the data collected, that collected data is also influenced by some facts, like from where I collect the data, from which season I collect the data, which day it is, that is, it is a holiday, how much frequency of automobiles are moving on the way, that is also influencing the data. That is the day temperature. So now, after taking the inputs, what we are doing in case of economics definition of production, we are using some technologies. So what are the technology here? The technology is the thermometer. These are the tools by which temperature details are collected. So thermometers are produced in some factories and purchased by the IMD. So there is also a chance of reading imperfect temperature data, because there may be some processing error of engineering, because thermometers are produced by some engineering techniques. There may be some fault in the engineering technique, because high chance of error is there, and some thermometers are not able to read the data perfectly. So there is also a chance of error. So error count also at the technology. And lastly, the output. That means the recorded data which is collected in terms of computer or by some human, like this, that is observing the marker level while they collect the data. And some modern technique that is through computers they read the data. But there is the possibility of error of reading data. But suppose if a human is collected, he collects data, and when he put it into the computer, he makes some error by putting some wrong data instead of the actual. There is a human error. If it is in machine, again the machine are produced somewhere, and there is a chance of error making the productions of the data. So true. These kinds of error is everywhere. And we are actually call them as noises. These are called noises. The noise is everywhere. So what we will do? So that is what we will do, because we cannot do anything without such noises. This noise you may expect or don't expect, it will be there. It will be waiting for us. So what we will do? So obviously the scientific thing is that we try to minimize this. So we try to minimize that error. That is resultant of why, that is the data, that IMD produced data or whatever you consider that kind of data recharge behavior of the students. That is effect caused by the variable, that is the variables which I am considering, which factors are causing these variables. That is, I'm interested to that, and the effect of noise created by the matrix. That means that in this relationship, how much noises are there, how much errors are there. So I just divide the relationship clearly in two parts. One part is deterministic. This part is purely deterministic. This is known by us, and we can handle this easily. But this part is not known to us, and this is quite difficult to handle. Is quite difficult to handle. So, in case of every type of analysis, not only in time series, but also in cross section data also, and in panel also, here we are considering this kind of blockage on the way of producing something. So now let us consider that is what type of data. I'm just considering here two type of data, that is one is cross section and there is time series, but except this you have to know there is another kind of data that is very interesting. There is a panel, but it is not our discussion today. Just shortly I'm making the distinction between the cross section and the time series. What is the cross section? So I consider the share price of 5 companies, and the very important to give me our provision. Profit of 5 companies and net profit of 5 companies and their share price. The company's share prices are given there. That means this is purely produced in some particular time, and this data is good, and these are actually time point data. These are called time point data. Cross section means you are dealing with the data at some particular point. But what is the distinction between the cross section and the time series? Suppose I consider what is the share price of Johnson and Johnson in 2020. That is $20. So this is the price. I'm not making what is the amount of error is there, or how much this data is pure in what sense. These questions are not coming actually in the but I think someone is
Excuse me, please. Someone is unmuted. We keep ourselves muted, please. Please keep yourself muted.
yes.
I request you all.
Yes, she will.
Please continue.
So in the time series analysis, what we are doing with historical data. We are doing with historical data, and I'm taking an example from that is very simple, because this thing is prepared for the students considering this already told me, and so I am starting with a very simple kind of data. And before going to that, any data kind of relationship, it is actually I have to show you through R. So I think the R screen is visible. This is the screen of R. If you download, I think it is okay now, Prabhuji?
Yes, it is clearly visible.
Okay. So look, when you there are two important things. Just it is free software. You just go to the Google and type RCRAN project. Will be downloaded in your C, that is C, and then you have to download another software, that is RStudio. And after that, you can just open the RStudio, not R. We are working on RStudio. Mind this. So when I open R, this page will just come, and there are the 4 things actually. Basically, there are the 4 things. So if I consider this is the first part where the data sets are there. This part, that is the top left part. This the data sets are there. And this is the second part. This is called the console part, and where we write out the command. And R is a command-based program. And the third one is this part. That is that is where which data set I'm working. And this fourth one is any diagram of this kind of thing will be there. So basically we are dealing with these 2 parts. That is where we write the command, and where we find out the figures or the charts or plotting this kind of things. So to open the first consider the data set. So here we are considering an example that is data of the age of the death of the successive kings of England, starting with William the Conqueror. That is original source is this that is mentioning, and actually the R is prepared. R is actually it is invented by Rob J. Handyman, and I'm taking his data and look how the data you have to consider. That is, here is the option that is import data. And it is a CSV file. So from text, we just go to CSV. So this URL will open, and you will make this copy paste and make it update. Then the data set will be coming to your. So this is the process. Okay, this is the process. Something. Okay. It is, yes, it is coming. It is coming. That is, this is the king's data. That is this is the data set you find, and this is the ages of the different ages of the kings. You can show that this is the data set. It's 42 kings data are there. There is only one data. I am dealing with only one data. This data is what is the date age of the different kings of England, starting something period in 18 something. Okay. So, considering this, we have to find out that we transfer this data into the R. But we transfer this data into the R. But R is what is problem is our problem of R, that R is not identified this data as time series. R is just considered this in the form of the image. So we have to transfer this into the time series. So we consider this and put this code in. And then I found the king's data. So no one looks, it is a puzzling like of things because comment like of things what I am copying and pasting, these are all available in Google free. You just go, this is nothing new. This is nothing new. No one concentrate on that this kind of comments are from where we get. It is available in R Blogger. It is available in Monash University website, everywhere. Because Indian data are not there. Not so much. India is not so much fast to update their everything. But in countries like Australia, New Zealand, USA, and this kind of countries, they are updating their every level of, except some confidential data. They are uploading every kind of data in the R. That is the advantage of R. And this is showing to you that is the 42 observations that is transformed into the time series. That is the date is 60, 43, 67. These are the dates of different kings. So this is a time series analysis. And in this R is not identified, so we have to make some arrangement and we can rename the data. And what is the name of the data? We rename the data that is in the form of kings. That is I mentioned here. Then I give the name as kings. So the data is saved in time series in R. So now we have to know more detail about the data. So suppose we want to know what is the different specific features of the time series. So you consider this, that is, we mention it king's time series. And then I open the king's time series. Look, so what kind of information is up there? That is, since the years are not there in the data, years are not there. Years are given as 1, 2, 3, 4 like this, and the data are this. If it is in year form, then there will be starting 1 year and the end is 42, and the frequency is 1 year interval. So you find if you are dealing with the time series in your statistics already, the students. And then this is an yearly time series data. So this is an yearly time series data, and the data shows us the interval of 1 year consists of 42 informations of the date of different kings. So now I go to this is yearly data. Now I'm going to accept yearly, but there are some other kinds of data are also there. That is some intervals are there. This is there is sometimes the time series data set that we have made collected in a regular interval with less than 1 year. For example, monthly or quarterly data, and we can specify the number of times the data was collected per year by using the frequency parameter, and the function is what is used in R, the TS function. That is not important. That is also not important. So monthly TS data frequency is 12, quarterly time series data frequency is 4. So we have to specify the first year. That means, suppose for example, my year started in 1986, and it is half yearly data. Then I can put by this kind of notations. So I am going to the next example. That is an example of data set of the number of parts per month in New York City, and it is called historical data. Time series is actually dealing with basically the past data, and from the past data they are going to produce something. That is the number of parts per month in New York City from January 1946 to December 1959. So again we have to require some data set. So I have to import this, and again I'm going to there and import that one. So the data set is here. Yes, this is the data set. Look, these are the monthly data, because these are considered as the number of parts per month in New York City, started from 1946 and to December 1959. So these are the data set. So this is monthly, but R is not identified it as a monthly data. R is identified just as an image. So you have to transform like before again. So that is you have to prepare that type of command of this data set what you get, and then transform this. Look at the coding. This less than symbol and minus. This less than symbol and minus is what I name the data as birth time series. I name the data what birth time series is my new variable, and then less than that symbol and minus. That means it is the forming new variable. And how you form the variable? This is TS, that means time series of what parts, because original file is consisting of part frequencies. Part, that is I am given 12. That means it is monthly data, and start date is 1946, and one interval is given. So if I copy this and put it to the R. So look here one thing that is identified only by R. Before that is there are 168 items. So if I put this and then find out what is the data. These are the very basic things. So look, this is the data series. That is 1946 to 59 for each month data sets are given there. There is January, February, March, April, May, and every month, and considering again up to December. So these are the different paths of the students, and we open it platform. So similarly, I'm just making some fast. I'm going to another example, that is the monthly sales for souvenir shop at a beach resort town in Queensland, Australia. So these are the actually of genuine data. So I make again what you're practicing. So just showing you how to open this thing. Again, do this and make the update, and the data will be imported. So you import the data. So it comes here. It looks. These are the sales, monthly sales of a souvenir. They transform this. That is, make the souvenir as a variable. It comes if we find out that there are 84 items. So 84 items are there, and then again like before, just make some concessions, repeating the process, and again showing it in terms of time series. So look, this is the data set, like before, same data set. That is this the birth rate and this is the monthly sales. So these are the sales data. So these are the monthly data. So one is considered, one data is yearly data, and so different kinds of data are there. So how to without observing the figure, it is very tough for us because the data is now into the R platform. So let us now check how the data is shown over figure. This figure drawing method is known as plotting. So once you have read the time series data in R, so next step is usually to plot the time series data, and for this you can do what we can do this kind of language, that is plot.ts. That means the plot.ts of what is the name of the variable you plotted here. So for example, suppose that it is the king's day. I just consider this one and put it here. So these are the different dates of the number of the kings is here. That is actually basically these are the different dates of the king series, and these are the different times. That is 1, 2, 3, 4, 5, 6. These are the years actually, and these are the dates. These two are plotted. So we can see from the time plot that the time series could not probably describe using an identity model or what you doing compare, that is multiplicative model. That those things will come later. So similarly, if we plot the birth data, if we plot the birth time series data of the different US children, then so this is the birth data. So look at the behavior, that is these are the years and the birth. What is the advantage of R? One thing, that is past drawing is here, and you can also zoom it here from making it, copy it. That is right click for copy the image, and you can put it here. Everything, these are the advantages. And what is this? Is the birth rate data, and this is the birth time. So you can see, what we can see. That is, look at the data very carefully. You can see what. That there are some seasonal variation in the number of births per month. That these are the monthly data. You know that this data is here. This is the data that is the birth time series. And this data, when we plot it, it looks like this. And it looks that suppose in January 1946, 26.660, then 23.598, then 20. So there is a seasonal variations. That means over the month there is a variation of the data. So there is some seasonal variation kind of thing, and this is what is called the seasonal. I will come to that later. So it seems that the time series could not probably be described as something that is additive model of this time. So that will come later. And again, in case of souvenir sales, if I plot the data, it looks like everything like the same. If I plot the data here, and it looks like this. This is another behavior. That is another behavior that you find that is from 1990 to 91. There is in 1 month it will comes up some extreme limits. It looks like this kind of behavior. So it may be some R software. It may be explained by like this. It includes such type of R learning that is on online mode. If you try to learn R from any online source, then you find that this is called that is seasonality. That is in any season. For example, the air passengers are moving from one city to another city. And if you found, for Bengali, suppose if you found that the number of travelers coming to Kolkata by the airline, so you find that during October or during September, this is increases because as per the purpose of the Durga Puja. So everyone is visited there. So there is a seasonality kinds of things. So there is another thing, that is we can transform some. Why I am showing this, I will come to later. We can transform the souvenir data in terms of the logarithmic series. So if I take that means what I am doing, that is these are the souvenir data. I change the data by taking its log. That means every data I take its log, and then if I plot that log souvenir series, the figure looks like this. The earlier one looks like the earlier one looks like this. And then if I plot it over the R, then it will gives us this kind of thing. Look, the seasonality behavior is quite prominent now. That is, over the time it becomes quite prominent. Earlier the behavior looks like this. Now when I consider the log, it becomes quite prominent. That is, you can observe each and every month's behavior from the data. So I'm considering an example like I'm considering some example like some theoretical backgrounds. That is, these are examples of airline passengers in USA. And if you observe this data, that is for every month from 1949 to 1960, number of air passengers moving from one city to another, and you find that during June, July, and August, the number is quite high every time. So, and then it is reduces, it is increases, and then it is reduces up to the November, and then again December it is increases, January it is increases. So I'm coming to that. So TS. Yeah, time series, for example, suppose any individual data types, suppose like cross section, that means what I am saying earlier, that is Johnson shares in 2020 is this I am considering, but in time series, it is something different. If I consider a data, if I consider a data like this, that is suppose 374, that is 1956 June. That is 1956 June data. This data, if I consider this data, that is 374, and it is changes to 413 in July, and which was 318 in May. So each and every data progress by such. But look in cross section, such things is not possible because you are considered there. You are fixing there at some particular value. So when we incorporate the time within the data, there is something more. More is what? That is, it is expressed as something changing, something developing, something growth, something deceleration. So we don't look 374 as 374. We don't look this 374 as a data just 370. Look it in terms of 4 components. That is, how much time influencing over time, how the 374 behavior is changing. This is called trend in time series. How much seasonal factors like this, that is in July, August, the movement over the passengers over the city influences, that is the seasonality. There is an S. And if over time, suppose a continuous over time, it is from 10 years or 15 years, after 10 years or 15 years, we found that some things like I'll come to that. That is known as cyclicity. There is some cyclical observations of the. I'll come into that example in this last. And there are some irregular I. That is the unobserved facts. This I is that unobservable facts which I discussed earlier. So in this 374 data, do not interpret any time series data as a numerical figure. You have to interpret data in time series data in terms of what is the time components within it, what is the trend of it, over time it is behavior, and what is the seasonal effects within it, what is the cyclical things within it. For example, if we look at the January of 1949. That is 112. Now look at the January data of 1960. That is 470. So not only the observed all data of January, but each year, starting from 1949, every time the number of the passengers increases or decreases, whatever it is changing. So over time from 1949 to 60, the data of passenger increases. Such a factor is called trend. So such a factor is called trend. So to consider this data, this data is actually in my computer already. That is the data of air passenger. So I am not going to that download it. So I just open it, data of air passenger. So then classify this data. That it gives us information that it is a TS. R identified time series, that's TS. So it gives me the information that it is a time series data. And what is the start and the frequency and the gain, this kind of things. And so there is 144 because 12 months and 12 years, 12 days is there in the data. That data is actually in the is I am showing you. This is the data set, and there is 144 data, and then we have to make a layout. And then we have to plot the data. And this is the presented data over the years. That is over the years starting from 1949 to 1960 over each and every month that is shown here. So after plotting this data, what we will do, that is to make a box plot to observe the seasonality. Not everywhere we are using the box plot, but it is something different. So box plot is what? Box plot is if you don't have any idea, that is box plot is showing a 5 points of a data. 5 points of a data series. What is the 5 points? That is, this is the first quadrant. This lower line is the first quadrant. And this is the minimum value. This is first line, and this is the highest value, the maximum line. The maximum value among the data set of a presented is the first quadrant, second quadrant, and the third quadrant is the median. So you find the median here. That is median is 200 and 300. In between 200 and 300 or like 300 something. And this is the median value. So it is the identifier that how my distribution is, what type of my distribution is. So if I plot the data in general Excel, that is, if I plot this that times the data in a general Excel, the diagram, it gives you this type of data. So from here you clearly find out that the number of passengers, these are the different years data marked by the different colors. So you find that what I'm telling you earlier, that in July and August, the number of passengers increases, then it decreases, then again increases in December and January. That is in the Western countries, it is the Christmas, and it is the fall season. That is the summer is there. So why the number of passengers they are moving from here and there? So the number of passengers increases, and in case of winter, this is the same thing. So these are the seasonal effects of July and August. And for example, what is cyclicity? I am coming to that. What is cyclicity? To observe this cyclicity type of factors, we are considering, for example, suppose some, especially for economic and commerce, we observe that during economic upstreams or downstreams, the behavior of the economic variable changes uncertainly. For example, for example, in case of introduction of pay commission, in case of government employees, after every 10 years interval, it is found that the booking of the new flats increases. That means after 10 years, you find something jump is there. That is in the real estate market. So due to this jump in basic income, because as pay commission increases the basic income, people have become interested to make some fixed asset like flat. And that is observed the demand for housing over a long period. If you observe this kind of data, that is what is the demand for housing over a long period. Then after an announcement of the pay commission, you find that there is some jump. That is the cyclical effects. So that is the full explanation of 374 data. There are some main component, there are some seasonal component, there are some cyclical component, and there are some unobservable facts like irregular behavior. So how to know what are the facts? That is how to decompose such facts. That is I am just giving you some ideas. That is the moving average, and that is decomposing of the time series. That is what we are doing. That is an irregular component is there. So consider this. This is a famous that is approach of time series for decomposition for the decomposition of non-seasonal data. This is not seasonal. This is like the death rate of the death age of the kings. What I discussed earlier. This is the data series. And what I am taking 3 years moving average, and you know that is I am taking the first 3 values and make its average. Then I take the next 2 values and make its average. By this way, I am arranging in some books in your what you are learning in your undergraduate level, like NG Dash or this kind of books. They have put this data from here. But that means one gap in this side and one gap in this side. But I actually put here because gap is in one side. That is not a significant factor. So here the value becomes this, and we will just find out the gap, that is the error, that is if I'm making the differences of these two data. And then again a double MA is produced, that is again a 3 months, suppose 3 years moving average is done, that is this data is started at this 38, 40, 42 started from here. So ultimately there is a 4 period lag is there is a 4 period lag is there, and again I have to calculate the error, and that error factor is to identified everywhere when I'm going to, because the data is like this, and that means from here I can say that the 2 is a factor is working everywhere. For giving in the sense like what is the effect of time, that is the effect of time in the case of peak time periods, that is 2. That is the train, and that is a marked here train. And here I am taking an example of a constant train, and what is my prediction? My predicted value is what? That is this value. That is this value consisting of the error and plus the train. This is the prediction, but that is a very difficult thing because prediction is another part of the times. We are not going to that. So what is the moving average? Moving average is this. And when I am considering the double, that is double period moving average, I think it is so much time, and there is a mathematics is there. So I'm just making the avoid that kind of mathematics, not going to those. Just I'm going to decompositions into R. So for this I require a package, that is the library, that is the TTR. So it is already have in my R. So otherwise you have to install the library TTR. Otherwise you have to write here, for example I'm showing, just write install, look, it comes. This is the advantage of R. If you write install dot packages, then the one bracket is comes, and then you put there this symbol, that is within the inverted comma, you just write TTR there. You just write TTR. Then the TTR package will come around. This is the advantage of R. The R is very, very user friendly. So just through Google, without making any course from anywhere, you just make this kind of command and put this, and the TTR will be there, because TTR will help us to decompose the that kind of time series. So I am going to that is that decompositions, and then after making this, I consider the moving average of King's data, that is King's time series, and I take the 3 years moving average. So yes, so then I plot this. Look how the variable form, that is King's time series simple moving average SMA 3 years. That is I name it. You can name it by X, Y, Z, whatever, but you have to put the name that you can rename, you can recall it. So how this construct, that is, I am telling earlier, that is less than and minus, that is the symbol of construction variable. So this is the new variable, and then you write this one, that is what you are doing. SMA is the tools, that is R used known to make the simple moving average of what King's time series with how many moving years you are considering 3 years. So then you can go to plot the data, that is in R, and it will gives us this. Look, just go to the earlier picture. This is my earlier picture. One cannot say anything from here. There is prediction, kind of thing. One cannot say what will be the next date year of that king. If I make some such a type of comments. Here, the interesting thing is that the picture is quite clear. That means you find that after this 19th or 18th period, there is a fall in the datage, and then again the rise in the datage. There is a fall, and so something is quite better. So make it smoother. There is lot of random fluctuations in the time series. I make it 8 years the moving average. Now look what is that. If I consider the moving average of 8 years, and then again plot it, So look, it is now becomes very much clear to us. It is now becomes very much clear to us. It's showing a downtrend up to this 20 and then it is increased. That means this is up to the 20th year because the date of death year is not mentioned in there 1, 2, 3, 4 month in case of King's Gate data. So I found that the kings are becomes dead at some lower age up to this 20 years, and now after that it is increased. That means that their age of death is increased. So these kinds of behavior we can interpret from this thing. So for example, if we decompose this birth time series, that is the children birth of New York City, then what thing is there? So if I can consider the seasonality, for example, birth, in case of birth, there are some seasonal effects. So considering some seasonal effect, this seasonal effect is there because this is the data set of birth. Yes, this is the data set of birth. You just recall that the different months birth started from some specific year in 1942 suppose, and from 1959 it is. So that birth rate is now changes to when I make the seasonal adjustment. We seasonalize the data in NG-. If you have the becomes to honor students or economics honor students, if you are go through the NG-, you just open the time series chapter and you just go to that practice that those exercises which are doing there, that is deseasonalization of data set. That deseasonalization is done by the R here. It is such a data. It is such a data. Look at the data behavior that in the month of January, in the month of February, this is appropriate with that NG-. Example. So why I am taking it? Because for each and every year, the seasonality adjusted factors are equal. Look, in January, February, all the values are equal. But this is not mandatory yet. This maybe changes. For example, if I take the birth time series of that in terms of trend, if I consider this is for seasonality, it will be same, but for trend it is not same. Look, the behavior is changing. That is, if I consider the trend factor, the behavior is changing. So in case of seasonality, the deseasonalization is done by each and every year. That is done by, for January it is 0.67719%. For February it is minus 2.082967. So these kind of things are there. And similarly for the trend, but for trend this is not equal. Look, it is 22.3535, and it is in 1958 it becomes 27.666. So this for trend this is not equal. Even for example, the random component, that is the things like unobservable errors, this is not the same. Very much different. And these are the data of random fluctuations for the January, February, March, and every month. So each and every values are different. So here, in case of seasonality, found that the values are almost means everyone is same for each and every month, for each and every year. Here we found some values are close to each other but different, and here we found in case of errors, that is the irregularities, each and every values are different, even in sign, even in values, whatever. So after coming to that, what I'm going to show you, that is if we plot this component, that is all the components, that is seasonality, trend, irregularity, everything. If we want to plot, what will come? That is, looks the figure. This is the original data. Original data of what? Original data of the birth of the children. And this is the trend factor. From here you can imagine that it is what time it increases. And this is the seasonal. That means in this month we find the data is minimum. In this month it is increasing. In this month it is top, that is maximum. Look, so there is some monthly variations, and this is the random behavior. So we can identify from a data that what is my trend, what is my seasonality, and what is my randomness. So now we can separate this from the original data. For example, Indian GDP. Suppose Indian GDP will take last 50 years, and from this yearly there are some economic happenings in 1991, and in COVID period, and so many unhappened things are there, cyclical factors are there. So you can do the thing except this, without these influences, how my GDP behaves, how the GDP of the country behaves. That means you are separating the train factor. That means that from that 374 is equal to, I am writing T plus S plus C plus I. That means I am removing T from there. That means what is the influence of time? I am remove it from the data. What is the influence of seasonality? I remove it from the data. What is the influence of cyclicity? I remove it from the data. And what is the influence of the randomness? That is the errors. I remove it from. Then what remaining is there? That is the actual GDP of one country. That means you can remove the train factors, this kind of things are there. So this is the thing, and you can adjust this seasonality. That is in this bath time series data. If I want to adjust this, look. This is the behavior of what after making adjustment of randomness, trained. So look, the data more or less going in the same pattern. Is going in the same pattern. Fluctuations are there, but this is the pure data you can consider. That is, we are making some filtering of the data. We are making some filtering of the data, and then we just prepare this. That is the process. And that this is the very first step. And there is another thing I prepared. I don't know whether the time is there or not, because for such kinds of filtering there are some different ways, and that is first one way is exponential moving. That is how to make smooth, how to make shape your data. That is the important thing. I think whether I stop here or.
I think Shubhashita will take some questions. Yes.
Okay. That is better. So today I will stop here. Thank you everybody for listening. I don't know how much it is satisfactory or not. Okay. I think actually R by this way is quite because you have to. But don't make any puzzle. Why? So I am telling that R is nothing new. It is there, and now what is happening in the world, that is this kind of software like SPSS, this data, it will become obsolete after 10 or 15 years. Those becomes purely obsolete, and only the software, and what is the advantage of the software? You do not require any money or this kind of things. It is freely available. You do not learn command from anywhere. You just go to the blogger or just type what will be my comment to derive the train equation to get that. So why I just initiate this, because you can start because today's there is one thing that is logistics services or analytics. It is the era of analytics. That is analysis of the data, and time series is not only the time series, each and everything is smoothly done by the graphs, the figures, the plots. Those are marvelous in R. But those are not produced in SPSS or these kinds of. Okay. So if you have any questions, you can ask.
Thank you, Shubhashita, for your wonderful, elaborate, and lucid lecture. We really enjoyed and we learned immensely. I think if this was an open lecture, offline lecture, if I was present, and I will give a standing ovation to you for your very lucid. You very wonderfully described all the nuances of time series data analysis, and not only that, we came to learn a new software, which is, I think it is new to me, and it will be new to any other scholars, any other students, and it will be very handy. And I think we will arrange another session for you so that you can then elaborately discuss about some other nuances and some other factors of art studio. You analyze how to decompose the data, how to identify the trend, seasonal, cyclical, and irregularities in the time series data, and you have just touched this. What is the functional relationship, deterministic relationship, and how to minimize this white noise error. So we learned immensely. Now I just searched the inbox. So I think there is no question among the students because your explanation and your lecture was self-explanatory in nature. It is very much lucid. I think if anybody among you have any question, you can unmute yourself. Among the teachers also, you can unmute yourself and ask the question.
বাংলাতেও জিজ্ঞেস করতে পারে তমজি, কোনো অসুবিধা
হ্যাঁ, যদি তোমাদের কোনো প্রশ্ন বুঝতে কোনো অসুবিধা হয়, পরিষ্কার করে তোমরা আনমিউট করে বলতে পারো তোমরা লেখনি। যদি কারোর কোনো প্রশ্ন থাকে তোমরা নির্ভয়ে জিজ্ঞাসা করতে পারো। I think there is no question. Okay, so thank you very much, Subhasish. Then I'd like to request Professor Sushobhan Mondol, head of the Department of Economics, Cooch Behar College, to present the vote of thanks.
Thank you, Tamaji sir. Respected principal sir, honorable speaker of today's lecture, head of departments and faculties, my dear students, a very good afternoon to all of you. On behalf of Cooch Behar College, its entire fraternity and the organizing departments, I feel immense pleasure to take this opportunity to propose a vote of thanks to our eminent speaker, Professor subhasish Bhattachariya, Department of Economics of Sidhu-Kanu Vishwa University, to spare the time from his busy schedule to grace this special lecture series, which is organized by Department of Commerce, Department of Economics, and Department of BBA. Topic of today's lecture was very relevant and interesting. It's been a very fascinating and engaging lecture. Thank you, Subhasish sir, for your effort to prepare these lecture slides, which are very well prepared and comprehensive. I am sure that our students have definitely benefited from this lecture. As you all know that Department of Commerce, Department of Economics, and Department of BBA have been organizing a series of special lectures, and today's lecture is also a part of this series. So I would like to thank our respected principal sir for always encouraging us and providing us this opportunity to organizing this lecture series. I would like to express my sincere thanks to Head Department of Commerce, Professor Abhijit Roy sir, for taking this initiative and providing all of us this opportunity to get connected with Professor subhasish Bhattacharya. I would like to thank all other faculty members of Department of Commerce, Department of Economics, Department of BBA, and my dear students who have been assisting continuously from behind to organizing this lecture series. My deep sense of appreciation and thanks to all the participants who chose to be with us and attended the special lecture with great enthusiasm and made it successful. My sincere gratitude also goes to the organizing departments for choosing such a nice topic which really matters in today's age and time. Last but surely not the least, I want to thank Professor Suman Sarkar for providing us technical support. Once again, I thank you all for being with us in this afternoon. I will not take much of your time and request Tomoji sir to move into the next stages of program. Thank you, Subhasish sir. Thank you again.
Thank you, Sushobhan Mondol sir, for a wonderful vote of thanks. Now, this is the last part of our today's lecture. So I would like to request Abhijit Roy sir to conclude this session.
Thank you. Thank you all. Thank you, Subhasish, for a nice presentation. It was indeed a self-explanatory presentation, and also the package is very much new to us. We all has been benefited by this presentation, and I am sure that the students will get the benefit of this lecture in future when they will be in practice and also in their academic arena. Because this portion is very much within their syllabus, they will get the basic idea of this time series analysis from the book mentioned by Professor Bhattacharya, and also in their research area, it will be much beneficial for them. I hope that in future also we shall be able to organize offline lecture of such a package in our college as and when we shall get the opportunity, because this type of presentation is very much necessary for the researcher and scholars of the academic arena. Thank you, Subhasish, for nice presentation.
থ্যাংক ইউ তমজিৎকে শুধু আমার একটা কথা জিজ্ঞেস করার আছে, আমার পার্সোনাল, সেটা কি তমজিৎ,
হ্যাঁ
তুমি তো ওই যে ফিল্মটা করেছো না,
হ্যাঁ
আমার আসলে সুন্দরবনের উপর একটা প্রজেক্ট চলছে, ওটাতে আমি মাইক্রো ফিল্ম বানাতে চাই। হ্যাঁ, সবাইকে ধন্যবাদ, সবাই খুব ভালো থাকো। আমার পুরোনো কলেজে এটা সুযোগ দেওয়ার জন্য তোমাদের সবাই কাছে আমি কৃতজ্ঞ, এবং খুব সুন্দর লাগলো আজকে। মণিমায়ের সাথে দেখা হলো না, যাই হোক দেখা হলে গলাটা শুনতে পেলে ভালো লাগতো। মণিমা আজকে আসতো, আর পরে হবে, ঠিক আছে অভিজিৎ, থ্যাংক ইউ।
আমরা তোমাকে এখনো মিস করি।
তোমাদের ন্যাক কবে সামনে কি